All right, so section 17.2 is all about rational exponents. So we're kind of breaking away, or what it seems like we're breaking away from the radicals for a little bit, but actually we're not. Believe it or not, we can write roots, square roots, cube roots, fourth roots, using rational exponents, aka fractional exponents. So if you look at this, this is going to be what gets you through this section. If you have a base raised to a fractional power, the denominator is always the root, and the numerator is always the exponent. So, there's two ways you can write it. You can write the nth root and keep your exponent on the inside, or you can write the nth root and keep your exponent on the outside. Typically, I tend to go this direction because this number gets rather large in here, and it's easier to take nth roots of smaller numbers, okay? So m is always the power, it's always the exponent, and then n is always the root. So basically what we're going to do is we have to do one extra step. We have to write it as a radical first, but then once we write it as a radical, it's what we were doing last Monday, okay? So the first thing we're going to do is, okay, who's this? This is the root, so we're going to be taking a square root. This is the exponent, okay? So we're going to write this, guys, as the square root of 4, and then we just can't forget to cube it, okay? So your root is always the denominator, so write that first, all right? So write it as your root. Since our denominator was a 2, it's the square root. And then once you write it as that root and break it down, after you get that number, then you're just going to raise it to whatever power that is. And so since it's a 3, we're going to raise it to the third power, all right? So what's the square root of 4? 2. So I just do the inside first. The square root of 4 is 2, but what do I still need to do? I'll get that in a second. I still need to cube it. And so what is 2 cubed? Anybody know offhand? It is 8. It's 2 times 2 times 2. Throw it in your calculator, 2 to the third power, you get 8. All right. On number 2, notice we have a negative, but the negative is not in parentheses, which means just let the negative hang out. So in my math lab right now, I'd be typing a negative. I know my answer is going to be negative, all right? So we're just going to let him hang out. The negative is just going to hang out, all right? And we're going to focus on this. 16 is going to be under what root? The fourth root. And once we take the fourth root of 16, what do we need to do? Raise it to what power?
To the third.
To the third. And that's just going to be the motion over and over again, okay? So that denominator is the root, and that exponent, that numerator, that 3 is the power. So you might know the fourth root of 16. If you don't, use our factor trees that we've been doing. What does 16 break up as? 4 and 4. But what do each of our 4s break up as? 2s. And what's the fourth root mean? It means you're looking for 4s. So what's the fourth root of 16? 2. The negative's still hanging out. The 2 is the fourth root of 16, but still, what can't we forget to do? Cube it. Alright? So this negative hangs out the whole time. We're not doing anything with the negative. We said the fourth root of 16 is 2. You can do that in your calculator, or you can break it down so the 2 pops out, but we still have to cube it. But then we just do 2 cubed over here. What was 2 cubed? 8. So what is this answer? Negative 8. You got it.
So you don't have a negative until the very end.
The very end. He kind of just hangs out in front because he was not in the parentheses. Now look at number 3. Number 3 is a little bit different because the negative's in the parentheses. All right. If the negative's in the parentheses, or anything's in the parentheses, it means that whole thing is going under the root. All right? So what's going to be under the root? Negative 27. What type of root are we going to be having? The third root. All right? Once you take the third root, what do we have to do? We have to square it. Is that okay, guys? Are you seeing where everything's coming from? So that denominator, that 3 is your root, and that numerator, that 2 is your power. All right, so we can take negative roots of odd powers. And so we just figure out what the cube root of 27 is, and the cube root of negative 27 is just going to be a negative version of that, right? Anybody have the cube root of negative 27 memorized? It is negative 3. So remember, this is still in the parentheses, so negative 3 is going to stay in the parentheses. And what do we still need to do? square it. But what happens when you square a negative? It will become positive. So this would be positive 9. Is that all right? 4, even though it looks scary, is probably one of the easiest ones, because since there is a variable in there and we don't know what that variable is, there's not a whole lot we can do, okay? So all we can do is write it in the radical notation, but then it's not possible to simplify. We're just done. So 4x minus 1, the whole thing is going to be under the root. What root, though? The 5th root. And we can raise it to the 3rd power on the inside to kind of match like this up here. Or we can do what we've been doing and just write the 5th root of 4x minus 1, the whole thing to the 3rd power. Either or is fine. Notice it matches both of these. The exponent can be on the inside, or the exponent can be on the outside. On here, I like it to be on the outside because we can break the inside down a little bit easier if it's small. Here, it doesn't really matter. So just make sure you know the root is the denominator, so it's the 5th root, and we're going to cube it one way or the other. Is that okay? All right, so that's basically what we're doing for the rest of the section, is just making sure we know that we can go back and forth, and if we can go back and forth, we'll know how to do these things. So 4 to the 1/2 power is another way of writing what? What root of 4?
2.
Yeah, the square root of 4, right? And what's the exponent? Just 1. So do we really need to raise it to the 1st power? No. So what's the square root of 4? 2. So all they want you to realize, guys, is writing roots like square roots and cube roots and so forth. Another way you can write them is with the exponent. So square root, another way to write square root is to the 1/2 power. So what's number 2 going to be? This is just the cube root of 64. Does anybody have the cube root of 64 memorized? The square root of 64 is 8, but what's the cube root of 64?
4.
It is 4, okay? If you don't know that, remember to break them down and do whatever you can. So this is just 4. The 4th root of 32, he didn't even need to be in this section. We're just going to break him down like we're used to breaking things down. So what are any two numbers that multiply to be 32? Four and 8. How does 4 break down? 2 and 2. How does 8 break down? 2 and 4. And then the 4 breaks down to 2. So believe it or not, 32 is actually 5 2s. Well, how is that going to help us? How many do we need in order to come out and play? 4. So 4 of them are going to hook arms and come out and play, but who remains on the inside? One of them, okay? When they come out as 1, remember? So 1, 2 will come out, and then we'll have the 4th root of 2 remaining. And that's a good review of what we did last Monday, right? Number 4, we're going to do the exact same idea, but we have to write it as the radical first, all right? So what root will we be taking on number 4? Yep, the square root of 9. And after we find out what the square root of 9 is, what power do we have to raise it to? The 3rd, right? What is the square root of 9? 3. But what is 3 to the 3rd? 27. Are you guys okay with that, where everything came from? The denominator is the root, so since that's 2, it's just a square root. And once you figure out the root, you raise it to the numerator's power. So we raised it to the 3rd power. All right, look at all this crazy stuff going on here. Oopsie, wrong way. So what we have going on here, guys, is kind of order of operations. What I'm going to do is I'm going to break the inside down first, and then I'm going to worry about squaring it. So basically, they have it like in this scenario. They have the root, and then we're going to cube it once we break down the root. All right, some of you might already know the cube root of 8, but if not, just break it down. 2 and 4, and 2 and 2. So what's the cube root of 8? 2, right? So inside the parentheses, a 2 can come out. How many x's can come out? Do you remember what that rule was? 2, right? We divide the index, this 3, into 6. How many times does 3 go into 6? Twice. So how many y's will come out? 3. So, when we break the radical down, just the radical itself is 2x squared y to the third, but what do we still need to do? Square it. A couple different ways you can do this. Squaring means take it times itself twice, but a kind of a quicker way to do that is you square the 2, because, right, we would have to take 2 times 2. You got to square the x, and you got to square the y, okay? So what is 2 squared? 4. What is x squared squared? X to the 4th. And what is y cubed squared? Y to the 6. As much as you want to square it, because, 3 squared is 9, remember when you multiply bases, you add exponents, okay? So where this is coming from is if we did this. Oopsie, you can't see it. I'm writing it down, you can't see it. So this is the long way of doing it, right? But we multiply everything, right? So 2 times 2 is 4. X squared times x squared, you add exponents, so that's x to the 4th. Y to the 3rd, y to the 3rd, you add exponents. And so that's kind of the shortcut. The shortcut is when you raise a power to a power, you multiply them. All right, let's do number 6. Again, this doesn't even have to be on this one, really. It is something we could have done last week. What is the cube root of negative 27? Negative 3, right? Yep, negative 3. And what's the cube root of x to the 9th? X to the... You got it. All right, 7 is one where we have to do some work, okay? I need your help, guys, because 576 is a really large number I don't feel comfortable with, but it's even. So what goes into it for sure? 2. So what's 576 divided by 2? 288, okay. 288 even, so I know 2 goes into it, and that's 144. And 144 I know is 12 squared, so that's 12 times 12. And 12 is 2 times 6, which is 2 times 3. And 12 is 2 times 6, which is 2 times 3. Oh gosh, look at all that. Is that okay how I did that, guys? Just find any two numbers that multiply to be that number, and then just keep breaking them down, breaking them down.
Can you go bigger, where like you see a 6, so you can do 6 or that? No, that's too big. Going too big.
Like with 576? Like,
Yeah.
yeah. Oh yeah. I just do it because I know it's even, so 2, but like 576 might be divisible by 6, so you can do 6 and whatever that is.
Okay.
Absolutely. There's not one, there's only one right way to do it. All right. So the index 3 tells us how many things we're looking for in order to come out and play. So here is one set of 2's that can come out and play. Do you see that? Okay. And then this one's kind of awkward. Here's another set of 2's that can come out and play. So it leaves this 3 and it leaves this 3. Is that okay? So 1 2 will come out, another 2 will come out, but a 3 and a 3 will remain. As they come out and as they remain, they're just multiplied. Okay? So if 2 2's are coming out, we have a 2 times a 2. Okay? How many x's will come out? 3 goes into 15 5 times, is that right? Evenly. Bless you. And then how many y's will come out? Well, 3 goes into 4 1 time evenly. Is that okay for the things that can come out? So we found one group of 2 and a second group of 2, so that's why we have 2 2's there. 3 goes into 15 5 times. 3 goes into 4 1 time. So that's how many total things can come out. Who remains under the cube root? 3 times 3. We had 2 3's under there. All the x's came out because 3 went into 15 evenly, but how many y's remain? 1. Because 3 went into 4 1 time with a remainder of 1. So I might be breaking it down way more than you need to. Like if you know 2 times 2 is 4, 4's coming out, that's fine, and 3 times 3 is 9, that's fine. So the final answer that my math lab's going to want is 4x to the 5th y times the cube root of 9y. 4x to the 5th y, can you see that? You know, is that okay? I don't know if that's in the way. Cube, and again, this isn't really even new to this section. I don't know if they're just kind of doing it more as a review, because we didn't do anything with exponents, right? I mean, this is basically what we did on Monday of last week. All right, here on number 8, what I do is I always try to reduce first. So notice 15 and 18 are both divisible by what number? 2, right? So we can actually write this as the square root of 25 over 9. Is that okay? All I did was just divide both by 2. And it's still under the square root. So we haven't done anything with the root yet, but now that we've reduced it, what do you notice about both 25 and 9? They're special numbers. Why? They're not prime, they're both perfect squares, right? What's the square root of 25? 5. What's the square root of 9? 3. So originally when you look at 50 and 18, you're like, I don't know what to do with these numbers. But once we broke them down to that, they're both perfect squares. So what's the square root of 25 over 9? Any arguments there? Where was 25 located? On top, so where does his square root come? On top. Where was the 9 located? On the bottom, so where's his square root going to come out? On the bottom. Is that okay? And do you guys agree if you take 5/3 times 5/3, you get 25/9? 5 times 5 is 25, 3 times 3 is 9. Are there any questions on that front page? That's your final answer. Alright, so on the back is where it gets kind of nitty-gritty with all the different rules. So we put this chart back in there for you guys. That was on the 17.1, 17.3 notes from last week. Just kind of reminding you of all the different rules. Remember, I think we added on here, if you have 1 over a to the negative n, that's a to the n. And basically, I'm just letting you guys know, if you have a negative exponent, he just means he's in the wrong spot. So here, if you have a negative exponent, he needs to be bumped to the bottom. But here, if the negative exponent's already in the bottom, bump him to the top, all right? So we're going to be using those rules plus some of these rules up here to get us through 1 through 11. All right. So the very first thing is use the properties of exponents to simplify, write with only positive exponents. So right now, what do we have? We have x to a negative 5th. So negative 5 means I'm in the wrong spot, so where does he need to go? To the basement. So this is just 1 over x to the 5th. It's just using this negative exponent rule. If you have a negative exponent, he's in the wrong spot. Do we know what x is? No. So can we raise it to the 5th power? No. So guess what? You're done. What about number 2, though? Do you guys agree that it's a negative exponent again? Yeah. So how are we going to write this? 1 to 3 to the 2nd power. Notice once you put them in the right spot, the negative goes away, right? This negative n changed to a positive n once he was relocated. So this negative 5 changed to a positive 5, and this negative 2 changed to a positive 2. You put this into my math lab, and what are they going to do? They'll say, although your answer is correct, it's not completely simplified. Why? Because we know what 3 squared is. What is 3 squared? 9. So the final answer, guys, is 1/9. So if it's a number and you can actually raise it to that exponent, go the extra step. But like on number 1, we didn't know what x was, so x to the 5th is just x to the 5th. We couldn't do anything more with it. All right, look at this. They're trying to make it all complicated on us. So what this is a combination of what we just did in number 2 with what we did on the front page with 3/2 and all that crazy stuff, okay? So what's the negative exponent telling us? It needs to go in the bottom. So there he is in the bottom in the right spot. But since there's a number there, guys, and no variable, we should know what 9 to the 3/2 power is. So what we're going to do, we have to keep in mind that he's in the bottom. How can we write this as a root to an exponent? What root are we taking? You got it, the square root. And once we take the square root, what are we going to do to it? Cube it. So that's just using the rules that we learned on the front page. The denominator is your root, the numerator is your exponent. What is the square root of 9? 3. But what is 3 cubed? You guys follow all the steps? So the first step was the negative exponent means go to the bottom. And then basically on the denominator we did everything on the front page, but we just had to remind ourselves he's under 1 the whole time, right? So 9 to the 3 half power, since this denominator is a square root, since that's the numerator, that's the power. The square root of 9 is 3. 3 cubed is 27. So when it's all said and done, guys, that answer is 1 to the 27th. I know, there's a lot of steps there. Look at number 4. Here's an example of the thing I just had us write right here. If you have a negative exponent, he's just screaming, I'm in the wrong spot. So if he's in the denominator, where does he need to go? Up top, and then his exponent becomes positive. But what's 5 squared?
10.
Nope. 5 times 5. Right? Now, you want to do 5 times 2, right? But if I wanted 5 times 2, I wouldn't make the 2 tiny, right? So the exponent means 5 times 5, or 25. Which is crazy to think, guys. 1 over 5 to the negative second power is the same thing as 25. It's really weird to think about. 5 and 6 are a lot easier. The reason why they're on here is to make you pay attention to where the exponent is. That negative 2 is only with the x. Why? Because there are no parentheses around the 3x, okay? So who's the only guy that has to move? Just this x, okay? Where does he need to go since it's a negative exponent? On the bottom. But who stays on top?
About 3.
That 3, okay? And who's the one that has to move? The x. And what's his new exponent?
2.
A positive 2. And that's all we can do. We don't know what x is, so we can't square it, so he's going to stay like that. Guys, number 6 is the exact same thing, but the opposite. Notice again, there's no parentheses around 9x, so this negative 2 is only with the x. So he's the one that needs to move. So where does he need to move to? The top. So he's going to join 4, so we're going to have 4x squared, and who's going to stay on the bottom? The 9. You got it. So just pay attention to that. If there was parentheses, the whole thing would move up top, right? There's parentheses around the 9x, the 9, and the x. But if there's no parentheses, it's just what's directly to the left, that x. On number 7, guys, this looks weird, but we've done it before. Like, what if that was just b to the first times b to the fifth? What do you do with exponents? What if that was just b to the first times b to the fifth? What do you do with exponents?
Combine them.
You combine them by doing what operation?
Times. No.
When you multiply bases, what do you do to the exponents? Add them, okay? So this is just b to the 1/3 plus 5/3. This one's not too bad to do because they already have the same denominator, but guys, anytime you have fractions, throw it in your calculator. Do 1 divided by 3 plus 5 divided by 3, and hit enter, and hit math frac or whatever. It'll give you the reduced fraction. 2. It's just 2, right? Because 1/3 plus 5/3 gives you 6/3, but 6 divided by 3 is just 2. So this is just b to the second power. Alright, so 8, guys, is honestly the nastiest one that you'll see, okay? There's a lot going on. I just want to remind you from the front, when we had this exponent on the outside, he went to every part, the 2, the x, the y. So when we have this exponent on the outside, this 5, he's going to go to the 2, the x, the y. So he's going to go to the 2, so he's going to be 2 to the 5th power. He's going to go to the x, so we'll have to do something with the 2/5 power. And he's going to go to the y, so we'll have to do something to the negative 1/3. The rule we're using is called the power rule. Whenever you have a power on the inside and you're raising it to a power, we're just going to multiply them, all right? So 2 doesn't really have an exponent right now, so he'll just become 2 to the 5th. And then x, technically what we're, guys, I'll write it, but if you can just do it, that's fine. 2/5 to the times 5, okay? We're going to do the power rule. Take the exponent that's already there, the 2/5 power, and times it by the exponent that's on the outside. And we'll do that in our calculator here in a second. And then we're going to have y to the negative 1/5, but what are we going to times them by? 5. basically what we've done is just distributed our 5 to each part, right? The 2 needs to be raised to the 5th power, the x to the 2/5 needs to be raised to the 5th power, and the y, that's not a 5, that's a 3, is that why you're questioning it? Sorry. Negative 1/3 needs to be raised to the 5th power. Who hangs out this whole time? X squared over y. Alright guys, let's go ahead and clean up the top. If it's a number, you actually know how to find the power. In your calculator, do 2 caret 5 and tell me what that is. 32, perfect. Here, we're going to have x to some power. What's 2/5 times 5? Again, in your calculator, you can just do 2 divided by 5 times 5. What do you get there? 2. And then we have y to the negative 1/3 times 5. In your calculator, do negative 1 divided by 3 times 5 and hit math frac. So negative 1/3 times 5 and then hit math frac. What do you get?
Negative 1.6.
Right, but then hit math over on the left side and then fraction, so enter.
Oh, 5/3.
And it always will change it. That's what's nice, it'll always change it to that fraction. So that's just negative to the 5/3 all over x squared y. Is that okay? So we distributed the 5 to each part, and then we clean it up. 2 to the 5th was 32. 2/5 times 5 was just 2, so it's just x squared. And then negative 1/3 times 5 was negative 5/3. At this point, is there anything obvious that's sticking out to you guys?
The 2 and the y.
The what?
The 2 and the x and the y, I'm sorry.
Yes. So we have 32 hanging out, but what do you notice about the x squared?
They cross out.
They cancel out completely, right? So he's going to be gone, and he's going to be gone. And then what does this guy with the negative mean? He needs to go where? To the bottom. So this, guys, is 32 over y times y to the positive 5/3, like that. Does that look okay? The 32, nothing is happening to him, so he stays up top. The y was already down there, so that's why he's there. And then the negative means go to the bottom. But what this ends up being, guys, is exactly what we did here. What did we do with these exponents? We added them. What is technically this guy's exponent? 1. So what's 1 plus 5/3? No, because we're going to add them. So what's 1 plus 5/3? Yeah, but what is that as an improper fraction? 8/3, yep. So this is going to be 32 over y to the 8/3. In yours, you accidentally typed 1/3, not 5/3. That's why you didn't get it. So 32 over y. So basically, what you're going to do is you'll get rid of parentheses first. You'll clean up as much as possible, and then you want to get all the x's together and all the y's together. So our x's happen to cancel out, but then we got our y's either at the top or bottom or cancel them out. You only want to write the y once, or the x once, if it does remain. Down here, it looks tricky, but it's not too bad. Just remember, whenever you're multiplying, you're just distributing. And when you distribute, you're just adding exponents, okay? So we're going to take x to the 2/3 times x to the 1/3, and x to the 3rd times, x to the 2/3 times x to the 5th. But we're just going to add the exponents. So we're going to have x to the 2/3 plus 1/3 minus x to the 2/3 plus 5. Because when we distribute, we're just multiplying. And when you multiply, you just add exponents. When you distribute, you're just multiplying. But when you multiply bases, you just add exponents, okay? So in my calculator, what I'm doing is I'm trying to come up with a new exponent. So x is going to be there for sure. But what's his new exponent? Well, what's 2/3 plus 1/3? 1, right? Just 3/3. Do you need to write to the first power? No, so I would just leave him as is. And then over here, this guy is going to be x to what power? I would do 2/3 plus 5 and hit math frac. What do you get on that one? 17/3. These are not like terms, right? X to the first and x to the 17/3 are two completely different things. So they just stay as is. Is that okay? And then we these last two guys is we're going to do the same rules we've been using, but we just have to go backwards. We have to change from radicals to exponents, okay? So how can we write the square root as an exponent? Well, the denominator is the root, so what root are we taking? The square root. And have we raised it to any power? No, so that's just x to the 1/2 power. So writing a square root is the same thing as writing to the 1/2 power. Why? Because the denominator is always the root, so square root is a 2, and then we don't have any kind of exponent in there, so the exponent is just technically 1. So how do we write the 1/4 root, the fourth root? It would be to the 1/4 power. Is that okay? Because again, what root are we taking? The fourth root, and where is he always located? In the denominator, and we haven't raised him into any power. At this point, we've changed them to number 7. What did we do with number 7? When we multiply bases, we add exponents. So this is just going to be x to the 1/2 plus the 1/4 power. X to the 3/4. You got it. We're going to do the exact same thing on number 11, guys. We're going to change each of them to the exponent first. And just remember, when you divide exponents, you're actually subtracting them, okay? So how can we rewrite x to the square root of x? X to what power?
To 1.
1/2, right? Why is it the 1/2? Because the square root's the denominator, so that's why it's a 2. How do we write the cube root of x? That's x to what power? 1/3. And we haven't had to use this rule yet, guys, but way up here, when you have bases divided, you subtract the exponents, right? So this will just be x to the 1/2 minus 1/3 power. And I would just throw that in my calculator. What do you guys get when you hit math frac? 1/6. And how do I know to stop there and not go back to a radical? It's because over here it says use the properties of exponents to simplify. Write your results with positive exponents. So it's hinting to you that it wants positive exponents. So we're okay to leave him as a 3/4 and him as the 1/6 power there.